Exploration. It is the key to discovering new fields and the starting point in their development. Geologists are the first to know where and how many reserves are to be found below the surface. Rapid technology advancement opens up new prospecting and exploration opportunities for oil and gas reserves. Utilizing sophisticated computer programs, the professional team at Gazprom Neft's Science and Technology Center simulate complex natural processes, restoring the evolution history of the entire geologic eras.
It is much cheaper to create a software product to conduct a series of studies and iterations using computer technologies rather than to find the truth on the ground by trial and error. By analyzing input data, we can repeat an experiment and run it through all over again for several times.
So that when the time comes to commercialize a new field, we are in a position to know where exactly commercial-grade reservoirs are located and how much hydrocarbons they contain.
A geological model essentially helps form a development system.
The process of creating an accurate model of a given field begins with shaping the geological structure of the whole region, covering hundreds of thousands of square kilometers. A model like that is termed a basin model. It helps identify potentially promising areas for further study.
A geological model is the cornerstone of decision-making as it impacts solutions in terms of field development and facilities installation, drilling and engineering.
Creating a model is a labor-intensive task that may take from several months to 1 year to accomplish, as it involves consolidating an array of heterogeneous data available from diverse studies.
This technology allows tracing a complete basin evolution history that might date back millions of years into the past.
We are aware of the potential locked in the massive tract of land we are analyzing.
Today, Gazprom Neft's Science and Technology Center is one of the leaders among Russian companies in applying this technology. When prospective areas are identified, the time comes to do fieldwork. For example, to collect data using geophysical studies, with seismic exploration being the most common type of study. Mobile shakers on the ground generate an acoustic wavelength that is reflected from geological boundaries and comes back to the surface. The recorded signal is integrated by personnel into the so-called seismic cubes, providing a more detailed view of the deep structure of the area. The next stage is prospecting and exploration drilling and collection of geophysical data on a reservoir. A range of tests are conducted downhole with core, rock, and hydrocarbon samples being taken. All of these are sent to a laboratory for analysis.
We analyze samples to establish reservoir and geochemical properties, which incorporate into the model, thus further refining it by way of iteration.
Reservoir models are built from obtained data. They summarize all available information and provide an estimate of reserves available in the field.
Relying on this model, we make further predictions. If any data deviates from the model, then our engineers start to dig up for any clue as to why such changes have occurred.
The ultimate result of work involving hundreds of people in regional studies, basin modeling, seismic and drilling activities, is an integrated and detailed geological model created by the Science and Technology Center staff. It lays the groundwork for the future field development plan and shows what wells are to be drilled and where they are to be best located to produce the maximum amount of oil at minimum cost.